Hi guys. So in our very first video on Java programming, we're actually not going to open the IDE today. I'm just going to take you through this concept known as Java fundamental data types, because this is, as it says, it's absolutely paramount that you sort of understand what these things are, and if you're going to write any serious Java program. Okay, and technically they're called fundamental data types because if it were possible to kind of take your a piece of software and sort of hammer it down, these would be the constituent elements or the atoms of every Java program. So you have to be familiar with these basic data types and what they can do and what you can use them for before we can sort of start writing actual Java programs by creating variables and functions and classes and stuff like that. So just to start, I've sort of made this table to kind of help you navigate this concept of fundamental data types. And we'll keep coming back to this table even when we open the IDE in the next video, for example, just to make sure. So if so you don't have to actually memorize all this. You can come back to this later if you need to refer to anything, or come back to this video basically. So Java has 8 fundamental data types, and the reason it has 8 fundamental data types is, in this case, there are 4 data types here which are integral data types, which means that you can store integers in these data types. These 2 types are decimal or floating point data types, which means if you want to store a number like 22.5 or 22.053, you would use a float or a double to store these values. You wouldn't use an integer, because if you wanted to store a decimal number in an integer, it would actually truncate the decimal point. So for example, 22.5 would actually become 22, and so that won't actually give you the precision you need when you're doing your mathematical calculations. One data type which is also crucial is the character or char or char data type. This is the data type which is used to build a concept known as strings, which you'll see in another video. So this is the fundamental data type that strings are dependent on, and this char or char string data type is really the one where you would store things like alphabets or symbols. It's really a symbolic data type in that sense. So it takes values between 0 and 65,535. What that means really is you can store these many different types of characters, right? So pretty much all spoken languages, you can store sort of each of their scripts in sort of these languages. And what does this mean? What does it mean when a character like an alphabet has a number to it? So just to give you an example, let's say you wanted to have the character capital A appear on the screen. Capital A in computers has a specific code to it. So I think that code is 65, but we can check that later. So the computer knows the code 65. The computer doesn't really care about A. It just makes a mapping between this code or code point 65 to the symbol that is capital A. So similarly, small a I think might be 98, but we'll check that too later. That has a code of 98. So the capital and small a, while we learn them together in English, they have actually different code points and they in programming languages, and this is constant no matter which programming language you learn. The last data point that I wanted to show you about these data types is Boolean, right? So a Boolean is really a data type that you would use when you want to make a decision between something happening and something else happening, right? So if you say, for example, if someone's age is less than 10 and that happens to be true, then do this. If it is false, then do something else, right? So that's what the Boolean data type is all about. Uh, Now each of these data types has a different size. Put another way, you can store different you can store different numbers in these types of data types. And what I mean by that, what I mean by different numbers is like a short can have the same amount of numbers or the same numbers that a byte has. An int will have the same numbers that a short or a byte has. A long will similarly have the same numbers that int, short, and byte have, but will have more numbers of its own because the size is 8, which means that in memory it can take up twice the amount of space as an int. Okay, and this works the same way for float and double. They are actually the same type of number in the sense that they are both decimal numbers, but the precisions are different, right? So you can store more precise numbers in double. The default data types that you will work with in Java generally are int and double. And when we get to the code editor in the next video, you'll actually see examples of all of them, but you'll actually see why int and double are special. And I'm sort of highlighting, sort of signaling, both of them out, because later on when we do examples, you'll see that actually when you write a number to in Java code, Java will either interpret that number as an int or as a double, depending on whether it has a decimal point or not by default. And then Java will see, after you give it an int or a double, Java will then look at the left hand side of your assignment and see whether it can fit that number in a byte, short, long, float, and double. So this is just a short video about the fundamental data types. These numbers of maximum and minimum, what it means really is that you can't store a number which is less than minus 128. So for example, minus 129, this won't fit in a byte because it's much smaller than this. On the other side, of the positive side of the number line, for example, you can't store a number like 128 in a byte. And when we get to the IDE in the next video, you'll actually see why, you'll see the errors that the IDE gives you and how you can sort of remedy it. So I think it's really important that you at least take away from this video that Java has these fundamental data types and what values you can store in it. It's actually pretty clear here. So any number between minus 32,768 and plus 32,767 can be stored in a short. And similarly for int, it's 2 billion and so on, right? So that's it for this video, and keep this video handy. We'll sort of, you'll have to come back to this video quite a few times, or rather keep this table in mind, and we'll see you in the next one. Thank you.